This set of videos is about variation of parameters, as I've written right here, which is another method we're going to use to solve non-homogeneous differential equations. These first couple videos, probably, it might be just one, but the process is quite long, are going to concern derivation of how the method works, and I'd really like you to try to just take in the details. I didn't put a whole lot in the skeleton notes for you to fill in during this process, just enough to kind of keep you engaged. But I do know that the derivation is quite long, so for those of you taking freehand notes, you might want to be aware of that before we start. But our little brief intro at the top of this section, just so that we know exactly what type of problem we're learning how to solve. This method is going to help us find particular solutions. Of a particular type of non-homogeneous differential equation. They're just going to be any second order non-homogeneous differential equations. That looks like 6 DEs. It's ODEs of the following form. We're going to have y double prime plus p of x y prime plus q of x times y equal to f of x. So these are our linear equations. And the way it's set up and the way that you will learn the process to solve, you do have to make sure that y double prime has like no function multiplied by it. If it does, we got to divide that out. Our overall approach is going to be that we assume y sub p takes the special form that it's some function u1 times y1 plus some function u2 times y2 for y1, y2 solutions in that fundamental solution set to the homogeneous ODE, y double prime plus p of x y prime plus q of x times y equal to 0. And u1, u2, some unknown functions that can depend on x. And finding those functions is what this method is all about. And as is often the case with an assumed solution, to find how you can calculate that u1, u2, we're going to start by plugging that assumed y sub p into our differential equation. So, you've got that down. We're going to start the derivation. And in order to plug y sub p into the ODE, we're going to need its derivatives first. And from the way that yp is set up, I hope you can see that this is going to be like a couple of product rules, so our derivatives are going to get pretty complicated. Things will simplify as we go on, but this first step is going to look very messy. So if yp is u1 y1 plus u2 y2, and we need the derivatives to plug into the ODE, we're going to find that yp prime, taking two product rules, first on u1, y1, we're going to get the derivative of u1 times y1 plus u1 times the derivative of y1. Then for the second term, u2, y2, we're going to get derivative u2 times y2 plus u2 times derivative y2. And then the derivative of that, first looking at these one type terms, we're going to get u1 double prime times y1, leaving y1 and taking derivative of u. And then I'm going to ask you all to remember from when we were doing reduction of order that when I take my second derivative of these two terms, I'm going to create one term that looks the same. I'm going to get that 2 times u1 prime y1 prime. 1 when I take derivative of y1 but leave u1 prime the same, and 1 when I take derivative of u1 and leave y1 prime the same. So I'm just going to combine them right there. And then my last term right here, u1 y1 prime, has the derivative u1 y1 double prime. If you still need to take that product rule manually and then combine, please do. I'm just keeping it a little bit shorter for these videos. And then applying exactly the same steps, but just switching 1 into 2, we get derivative of these second two terms right here. We're going to have u2 double prime y2 plus 2u2 prime y2 prime plus u2 y2 double prime. And that's yp and its derivatives that I'm going to have to plug into my differential equation. Obviously, I do not have room to do that on this slide, so I'm going to need to move over. Please pause if you're still trying to write out that very long derivative. So we want that f is equal to yp double prime plus p yp prime plus q y sub p. For the differential equation, we were given some p of x and some q of x. We're going to plug it in. So f, whatever's on the right-hand side, is going to have to be equal to y double prime, which was that very long derivative, u1 double prime y1 plus 2u1 prime y1 prime plus u1 y1 double prime plus u2 double prime y2 plus 2u2 prime y2 prime plus u2 y2 double prime. That's yp double prime. Plus p times yp prime, which was just that u1 prime y1 plus u1 y1 prime plus, same thing but 2, u2 prime y2 plus u2 y2 prime. Last one's the easiest, plus q times yp, which is just u1 y1 plus u2 y2. So we have successfully plugged in yp to the ODE. Eventually, we want to learn what u1 and u2 are. So I'm going to go ahead and group by terms that look like u1 and u2, kind of see what happens. So given this big mess of things, I'm going to write out all my terms that include u1. So first I'm going to underline them all for us so that we can see them. I've got u1 right there, and right there. So u1 is going to be multiplied by y1 double prime in my first term. Here, remember I have to distribute that p all the way through, so I'm going to have p times y1 prime. And here I'll have q times y1. And then I'll do the same with u2. So let's look for our u2 terms. There's one there, and one there. So that gives me a y2 double prime plus p y2 prime plus q y2. And then everything else, I'll go ahead and write down that I haven't done anything yet. I've got u1 double prime y1 plus 2u1 prime y1 prime plus u2 double prime y2 plus 2u2 prime y2 prime. So just want to make sure I'm actually getting everything. Got that one, got that one, I have that one, and that one. Great, and then plus p times u1 prime y1 plus u2 prime y2. Got those last ones. those are all my leftovers. We're not going to do anything with them yet. Real quick, I just want to note that y1 and y2 are solutions to the differential equation where, going to switch pages on you real quick, where y double prime plus py prime plus qy is equal to 0. So, since y1, y2 are going to satisfy y1 double prime plus py1 prime plus qy1 equal to 0, and same for y2. Oh no, I erased the wrong thing there. Or the homogeneous ODE, then these terms right here are actually going to go to 0 because y1 double prime plus py1 prime plus qy1 should be equal 0. Same for y2. So we're actually going to have that f is just equal to all that stuff down here because those top two terms just become 0. U2 prime, Y2 prime. 1, 2, 3, 4 terms, 1, 2, 3, 4 terms. Okay, I got them all. This is still a lot. I've got multiple U derivatives and Y derivatives hanging around. And so I'm going to try to combine some terms as much as is possible. And this step isn't really going to make sense. It's just a step that, I mean, it will make sense, but arriving at the reasoning for why we would do it is more difficult. This is just a thing that simplifies the equation. If you stared at it for a very long time, maybe it would occur to you, but maybe it wouldn't. What we're going to note is that this double derivative y1 plus single derivative u and y looks like when we take a derivative of a product. So this is kind of like when I'm thinking about taking derivative of u1 prime y1. So if I took this derivative, I would get first u1 double prime, leave y1, plus leave u1 prime and take derivative y1 prime. The only issue is that I have one leftover term of, there should be two of these, so I'm just going to note the extra one that belongs right there. And since the u1, u2 terms are exactly the same, I'm going to be able to do the same with this second term. Same reasoning makes it work. So then, because derivatives are linear, this is derivative of u1 prime y1 plus u2 prime y2. So I just combined these two derivative terms plus all the leftover stuff. u1 prime y1 prime plus u2 prime y2 prime. And I want to have this equal to f. Okay, so bear with me for just a second. Solving this equation would be very complicated, but we're going to use an argument that sort of, if f is equal to all this stuff, then if this term, which is the same when it's multiplied by p, and it appears taking a derivative, if that thing was 0, both those terms would go away. So we can solve this with the system where we make two of those terms just be 0, that u1 prime y1 plus u2 prime y2, the one that was multiplied by p and where we have the derivative, we just want it to disappear. And then once it's gone, we go ahead and solve for f equal to u1 prime y1 prime plus u2 prime y2 prime. If we could solve those equations, we would have the solution we need. And I'm going to pause here because in the next video, I will write out what you get when you try to solve those equations and the steps that you'll actually use to take advantage of that solution. Because this whole process is so complicated, I'm not going to expect you to be able to do it every time you have this type of problem. So, finish writing all that down, and I will see you in the next video.